Hey, what's up, pre-calculus? We're going to look a little more at finding equations of horizontal and oblique asymptotes. So just as a recap, we have already figured out the ins and outs of finding equations of horizontal asymptotes. It is all about comparing the degree. So if you do need more assistance with that, please consult prior videos. What we're going to get into now is it's kind of a wacky thing called an oblique asymptote, or sometimes we call it a slant asymptote. And we see an example of that right here on this function that is already graphed for it. There's this dashed line at the right end, and at the left end, our graph seems to get closer to that line. It is not horizontal. It is not vertical. It is, in fact, just a slanted, an oblique, or a line, okay? So let's figure out each limit and see what we can determine about this new kind of an asymptote. So first of all, I'd like to point out the degree of the numerator is t, the degree of the denominator is 1, and for that reason, top beats bottom, there is no horizontal asymptote. And if we look at the graph to determine the limit, in part A, we're going to look near the x value of -2. All right, so from the left, limit of f of x as x approaches -2 from the left is, well, look at that. The y values very drastically point downward. And as we evaluate the limit of f of x as x approaches -2 from the right, walking towards this value from the right, we do see that the y values shoot drastically upwards. So that is infinity. And yes, the equation of the vertical asymptote, when we see these infinite limits here, that equation must be x equals -2. No surprise. Go ahead and look at that denominator and you might already see the connection. I've already touched on this. Why doesn't this function have a horizontal asymptote? Well, how about you write what we already summarized up above. I spoke it out loud. You can write it down. Moving on to part D, though, this function does have an oblique asymptote, and I've already mentioned they are sometimes called slant asymptotes. They are written in the form y equals mx plus b. It is very important to have both variables there, y and x. And why don't we try to write the equation of the oblique asymptote just from looking at the graph. I'm going to hone in on the y-intercept of -1. Looks like coming out of there, and every point there is a slope of +1. I'm putting this together. There is the equation of the oblique asymptote. Okay, I'd like you to pause the video here and try out part E. Just use synthetic division to rewrite that function. And I'll be right back with you. Okay, welcome back everyone. Let's just admire my mug here. Goonies never say die. And if you take a peek inside of that mug, whoa, look at it. I am rich. I've got a lot of nickels. Oh boy. All right, here's how my division played out. I just performed some synthetic division. There is a remainder, that is worth noting. And when I did the division, oh my goodness. Look at the connection between how the division played out and how the oblique asymptote showed up on the graph. And if you think about this other version of the function, the x minus 1 with the remainder over x plus 2, gives us insight as to why. So as x gets very, very, very big, 3 divided by that big value of x gets closer and closer and closer to 0. That means the function itself, well, its value is mainly dictated by these two terms, not so much that term. And yes, the conclusion we then draw is, well, when you do the division, leave off the remainder, there's your oblique asymptote. I'll say that again in case you're not listening. To find the oblique asymptote, we do the division and leave out the remainder. Do the division, leave out the remainder. Okay, so this fact is summarized at the top of the next page. Oblique asymptotes, aka slant asymptotes, when we, think about the rational functions as the ratio of two polynomials, oblique asymptotes can occur when these two conditions are met. Two conditions. The degree of the numerator is exactly one higher than the degree of the denominator, and that's condition one. And condition two, the division produces a remainder. And if those two conditions are not met, you do not have an oblique asymptote. Okay, I'd like you to pause the video and bust out your division skills. Always wear your glasses to math class. It helps with division, okay? Just try out the division. If you can make the leap to determining the oblique asymptote, go for it. If not, I'll come back at the end and catch up to you. Okay, welcome back. Let's take a look at how the first two played out. In number 10, degree of numerator greater than degree of the denominator by 1. That's the first condition. We've got it. We performed the division. Don't forget about that missing power. And we got a remainder. That's condition 2. And now we can conclude there is an oblique asymptote. Make sure you are writing the full equation, y equals 2x plus 2. Without that y equals on any test or quiz, I'm taking off a point. So protect yourself from the point monster. Write me the full equation, okay? All right, number 11, degree of numerator is a 2. Degree of denominator is a 1. That's the first condition. When we perform the division, though, we got no remainder. So our second condition did not come through for us. Therefore, there's no oblique asymptote. Funny story, if you were to graph this function, you would just see a line, the line y equals 2x plus 3, but with a hole in it where we get to that undefined value of x equals negative 2. All right, moving on down to number 12. The degree of the numerator was 3. The degree of the denominator was only 1. Right away, you didn't even have to do work. There's no oblique asymptote because of that difference in the degrees 2. I will point out, though, I did the division anyway just to go a little extra, and that equation that's left would be a parabola. So if you were to graph this, you actually would see a parabolic asymptote of y equals x squared plus 3x minus 5. But yeah, that is not what I was asking. I was asking, is there oblique? And there's not. End of story. All right, in number 13, last one, degree of numerator, 3. Degree of denominator, 2. And okay, there we go. That beats it by 1. I performed the division. I got a remainder. That is my second condition. So my oblique asymptote, once again, please write the full equation. Forgetting about the y means you forget about one of your hard-earned points, but I will just do the division, leave out the remainder. Y equals x plus 3 is my oblique asymptote. That's all for now, everyone. Toodles!